So in this video, we are going to learn how we can differentiate the various trigonometric functions. That is the sine, cos, and then the tangent. So we are having the cos, let's see cos s, sine s, and then tan s, using the first principles. So let's take the cos. So you know that from the first principle is defined by the limit as h approaches 0 of s plus h minus f of x all over h. So whenever you are solving or differentiating an equation and then you use this method, it is called the first principle, or you are, in other words, you are using the first principle to differentiate that particular equation. So let's take the cos s. So f of x is equal to cos s. So in this case, wherever we see x, you just replace it by s plus h. So the derivative of f of x is equal to limit as h approaches 0 of cos, you're having x here, so s plus h minus f of x. F of x is the whole this thing, so cos s all over h. We're having this, and then we're having some trigonometric identities for cos, which says that cos A minus cos B is equal to minus 2 sine A plus B over 2 sine A minus B over 2. So this is the identity for cos A minus cos B. So we fix whatever is here to this part, but in this case our A is equal to s plus h, and then our B is equal to x. So we have something like the limit as h approaches 0 of the whole of this thing, because this thing now, we will fix this thing over here and then replace a and b by this and this. So we get minus 2 sine, our a is s plus h plus x all over 2 sine, our a is s plus h minus our b x all over 2, this whole thing over h. So let's take what is at the top and then solve it. So we get negative 2 sine 2x plus h all over 2 sine h over 2. And then with this one, we can write this as minus 2 sine 2x over 2 plus h over 2 sine h over 2. So we now get minus 2 sine x over 2. Sorry, this cancel this. We have x plus h over 2 sine h over 2. So we are now having this thing. We just fix this one over here. So we get the limit as h approaches 0 of minus 2 sine x plus h over 2 sine h over 2 all over h. So we can write this as limit as h approaches 0 of sine negative sine s plus h over 2 sine h over 2 all over h all over 2. Why am I saying this? When having something like 2b over c, you can write this as b over c over 2, because the reciprocal of this will give us 2b over c, which is equal to this one. So that is what's happening over here. So we are having this. We can write this also as limit as h approaches 0 of minus sine x plus h over 2 times limit as h approaches 0 of sine h over 2 all over h over 2. And then there is one property of limit which says limit as s approaches 0 of sine x over x is equal to 1. So that is what is also happening over here. You can see that sine h over 2 over h over 2 will give us 1. This whole thing is equal to 1. So we get limit as h approaches 0 of minus sine s plus h over 2. So here we fix in our zeros, we get minus sine x plus 0 over 2, which we get minus sine x. So let's take sine x. So f of x is equal to sine x. And then again, the first principle is defined by derivative of f of x is equal to the limit as h approaches 0 of f of s plus h minus f of x all over h. So wherever we see our x, we replace it by s plus h. So we get limit as h approaches 0 of sine s plus h minus f of x, which is sine x all over h. So there is also some identity for sine, which states that sine a minus sine b is equal to 2 cos a plus b all over 2 sine a minus b all over 2. So with this one, our a is equal to s plus h, b is equal to x. So let's fix it in. So we get 2 cos s plus h plus x over 2. And then we have sine s plus h minus x all over 2. So we get 2 cos s plus h over 2 sine h over 2. So what we have gotten over here is for the numerator. So we fix it over here. So we get limit as h approaches 0 of 2 cos s plus h over 2 sine h over 2 all over h. And then we can write this one as limit as h is equal to 0, h approaches 0, sorry, of cos s plus h over 2 sine h over 2 all over h over 2. And then we can write this as limit as h approaches 0 of cos s plus h over 2 times limit as h approaches 0 of sine h over 2 over h over 2. So this will give us 1. So we get limit as h approaches 0 of cos s plus h over 2. And then we're fixing our zeros. So we get cos s plus 0 over 2. And then we get cos s plus 0, which is cos s. That is absolute the derivative of sin x. So finally, let us consider f of x is equal to tan x. So the first principle is defined by derivative of f of x is equal to the limit as h approaches 0 of f into s plus h minus f of x all over h. So wherever we see x, then replace it by s plus h. So we get limit as h approaches 0 of tan s plus h minus tan x all over h. And then we have a property for an identity for tan, which says tan x plus h is equal to tan x plus tan h all over 1 minus tan x tan h. So we fix this one here. So we get limit as h approaches 0 of this one here. So we get tan x plus tan h all over 1 minus tan x tan h minus tan x all over h. So now let us consider what is at the top and then solve that one. So tan x plus tan h all over 1 minus tan x tan h minus tan x. So we find the LCM for this. So we get the LCM for this is 1 minus tan x tan h. And then 1 minus tan x tan h goes here 1. Multiply this, you get tan x plus tan h. So this one is over 1. So this one will go into this one. 1 minus tan x tan h. So we get minus tan x into 1 minus tan x tan h. So we multiply 2 by minus tan x. So we get tan x plus tan h minus tan x plus tan square x tan h all over 1 minus tan x tan h. And then you can see that minus tan x can cancel tan x. So this and this will go off, leaving tan h plus tan square x tan h all over 1 minus tan x tan h. So this is what we are having for the numerator. So we fix this one right here. So we get limit as h approaches 0 of tan h plus tan square x tan h all over 1 minus tan x tan h. So we can write this as limit as h approaches 0 of tan h plus tan square x tan h all over h into 1 minus tan x tan h, because I found the reciprocal of this and then I had this. So we have limit as h approaches 0. We can factorize tan h out. So we have tan h into 1 plus tan square x all over h into 1 minus tan x tan h. So now we can also write this as limit as h approaches 0 of tan h over h times limit as h approaches 0 of 1 plus tan square x over 1 minus tan x tan h. So tan h over tan h, this one we can do it as same as what we had at the first one. So it was 1 times limit as h approaches 0 of 1 plus tan square x all over 1 minus tan x tan h. So we fix in our zeros, we have, so this one multiply this, we get the same as this one. So we get 1 plus tan square x over 1 minus tan x into tan 0. And then this multiply this whole thing. Tan 0 is 0 times this one is 0. So we get 1 plus tan square x over 1 is equal to 1 plus tan square x. But we know that 1 plus tan square x is equal to sec square x. So when we combine the two, we have 1 times sec square x, which will give us sec square x.